So another type, again, you reduce the freshwater input relative to the tidal volume, to the significance of tidal mixing, and what you create is something that we call a slightly stratified estuary. And these types of estuaries are widespread in temperate and subtropical climates. Many examples are found around the world. And in this situation, there is a mixing between the upper and the lower layer. Okay, so the salinity structure that you find in these estuaries is salinity increases towards the sea. Okay, it's a gradual increase in both near the surface and near the bottom, but the bottom layer is always saltier compared to the surface layer. Okay, this is what we call a slightly stratified estuary. They have a moderate inflow and so. And just to explain that this salinity structure, actually you have the tides and you have the flows, okay, and they maintain a steady state salinity field. So this salinity field doesn't change, although if you chuck a float into that system, it actually will move in the surface layer towards the ocean or into the estuary at depth. Okay, so but the salinity field stays the same. So the movement of particles is actually across these isohalines. And here's one example. Okay, you measure the salinity in grams per kilogram. This is Chesapeake Bay again. Okay, you can see the low numbers on one side. And then over a distance of 60 kilometers, you get an increase. You're still not in the ocean, but you can see the structure. You have a enhanced effect of tides, which lead to a mixing between the surface and the bottom layer. And in these situations, you have a relatively broad brackish water zone, a relatively broad zone across which salinity changes. And this is over more than 60 kilometers, all right?